Hello, and welcome again. I'm Mr. Hicks. Let's talk about some chemistry. Today we're going to talk about stoichiometry. This is the second video in a series on stoichiometry that I have. And this time we're going to talk about how to do mass to mole problems. Previously, we saw that we can use what's known as the molar ratio to convert from one substance to another. Today, we're going to add on to that process by changing things to grams either before or after the use of that molar ratio. Let's see what a problem might look like. So here's a typical problem. Look up here and find our keywords. We have 0.4 moles of potassium, and we want to find out how many grams of hydrogen gas is it going to produce. So starting with my question mark format here, I'm looking for how many grams of hydrogen gas. And I want to know how many grams of hydrogen gas is equal to the use of 0.4 moles of potassium. Now last time we talked about using the molar ratio to make the switch between one substance and another. So in this case, we're changing from potassium to hydrogen gas. And we can do that using the molar ratio. But to use the molar ratio, I have to be in moles. So in this case, I'm already in moles. So now I can use that molar ratio by just setting up our dimensional analysis for it. On the bottom, in order to cancel, we're going to use moles of potassium. And on the top, we're going to put down what we want, which in this case is hydrogen, so we need to switch to hydrogen. And so I'm going to write moles of hydrogen. This is a molar ratio, so it's going to be moles over moles. It's going to be switching between two different substances, and I'm going to get these numbers to go in front of the mole from the balanced chemical equation. So if I look up here, I'll see with potassium, I have the number 2. So I'm going to put the 2 with the potassium. There's my coefficient 2, and I'm going to put the 2 down there. For hydrogen, I have a coefficient of 1, so I'll use that for the hydrogen. Crunch this out, and I get 0.2 moles of hydrogen. Here the potassiums are canceling, and I'm left with hydrogen. Now some of your teachers might make it so that you just continue on with another set of dimensional analysis fractions here. But I'm going to kind of show this in two different parts. Now, once I've found how many moles of hydrogen, I want to know how many grams. This we can do with our mole conversion between moles and grams. So I'm going to take that 0.2 moles of hydrogen, and I'm just going to change that to grams. So moles of hydrogen will go on the bottom, so I can cancel it out. And on the top, what I want is grams of hydrogen. Here I'm going to use 1 mole of hydrogen. Not because it's 1 mole up here, but because 1 mole of hydrogen is equal to 2 grams of hydrogen. Now if I multiply that, I find out that this will make 4 grams of hydrogen gas. How was that? Quick review. I had to make the switch because I was changing from potassium to hydrogen. To do that, I had to use my molar ratio. I have to be in moles in order to use the molar ratio. So the first step is always to change things to moles. Once it's in moles, use that molar ratio to make the switch to hydrogen. And then once I'm in hydrogen, I can figure out how many grams just by doing things with my molar conversions that I've learned from the past. All right, let's try another one. In fact, I'm going to let you give this one a try. We're going to take some propane. You can see here I have 10 moles of propane. And I want to know how many grams of carbon dioxide is it going to yield. You go ahead and press that pause button. Work this one out. And when you're done, I'll be right here. All right, how did you do? I bet you did fine. Let's start things off with our question mark format. How many grams of carbon dioxide can I make when I use 10 moles of propane? Setting things up, the first thing is I'm in moles. So if I'm in moles, I'm all ready to make the switch using my molar ratio. On the bottom, be moles of propane. And up here on the top, I'm going to put what I want to change it to, moles of carbon dioxide. So I'm going to get my numbers from the balanced equation because this is the molar ratio. So I have a 1 here in front of the propane and a 3 in front of the carbon dioxide. So I'll put those two numbers in right here. In doing that, I now see that I have 30 moles of carbon dioxide. Not done yet, because what I want is grams of carbon dioxide. But I know that I can take grams, I can get grams if I know what the moles are. So I'm going to take my 30 moles of carbon dioxide, and I'm going to convert this over to grams. On the bottom, I have moles of carbon dioxide. On the top, I'm going to put grams of carbon dioxide. Now this time, for moles, I'm going to put 1. A common mistake is that people will try to use this 3 again. We only use the 3 in the molar ratio when we're making the switch from one substance to another. Here, I'm just changing from moles to grams, and so I want to say that 1 mole is equal to 44 grams. Another common mistake is up here for the 44 grams, which we get from our periodic table. Sometimes people will say, well, I got 3 of those, so it should be 3 times 44. Don't do that either, because you've already taken into account for this 3 right here by using that in your molar ratio. If you were to multiply this by 3 and use it here again, you'd be doing double the work. And you get the answer wrong. All right, so now 30 times my 44, and that's a pretty big number, kind of scary sometimes, but that's all right. 1,320 grams of carbon dioxide. Okay, so we've seen how to take something and change it from moles, to grams. Why don't we try and change this up a little bit, and let's see if we can go from grams to moles. So here's another problem. I have 10 grams of magnesium, and my problem says, how many moles of hydrochloric acid is this going to be? So, let's work with our question mark format. How many moles of hydrochloric acid can I make, or will I need, to react with 10 grams of magnesium? Well, the first thing I want to do here is, put my G in there, first thing I want to do here is I have to make a switch between magnesium and hydrochloric acid, but I can't do it just yet. Because in order to use the molar ratio, I have to be in moles already. And as you can see from this, I'm in grams. So the first step I have to do is change it to moles. So that's what I'm going to do first. On the bottom, I'm going to put grams of magnesium. And on the top, I'll put a mole of magnesium. For the grams of magnesium, I get this from the periodic table, 24.3. And for moles, I'm going to use 1. Not because it's 1 here, but because 1 mole is equal to 24.3 grams of magnesium. Doing this on my calculator, I see that this is 0.412 moles of magnesium. Now that I have it converted into moles, now I'm able to use my molar ratio for the next part of this. So I'm going to take my 0.412 moles of magnesium, and here's where I use my molar ratio. I'm going to put moles of magnesium on the bottom, and on the top I'm going to make my switch to hydrochloric acid. Again, get my numbers from the balanced chemical equation. There's a 2 in front of the hydrochloric acid. There's a 1 in front of the magnesium. And doing this on my calculator then, I get 0.824 grams. Whoops, check that. Moles of hydrochloric acid. Okay, so we've seen one where we've changed it from moles to grams. We had to use our molar ratio and then change it to grams. This one, we switched it from a mass in grams to moles. We saw that we had to change it to moles first and then make the switch with the molar ratio. I have another problem here for you. In fact, 2 of them. One of them where you're going to have to change it from grams to moles, and then this one down here where we're going to change it from moles to grams. You press that pause button. Good luck with this. I'll be here when you're done. Okay. Well, while you were away, I took the chance to scribble out my work here. It's a lot. Let's see what I did. Up here, I was switching it from sodium chloride to chlorine gas. I started with grams of chlorine gas, so first I had to change it to moles, and then I could use my molar ratio to convert it into moles of sodium chloride. Down here, I started with moles. I wanted to know how many grams. So since I was in moles to begin with, I started right off with my molar ratio. Then I took the moles of chlorine and changed it to grams. All right, how was that? I bet you did great. And have fun with your chemistry, and I hope you come back for more.